2026 A-Level Combined Mathematics Paper 1 Part B question number 13 Part A. Parts B and C of the same question will be discussed in future videos. Links in top right. Part A of this question has to do with matrices. The question says, let the capital A matrix be the 2 by 3 matrix given by 2A1, 3, negative 1, 1. Let the capital B matrix be the 3 by 2 matrix given by negative 2, 0, B2, 2, 3, and let the capital C matrix be the 2 by 2 matrix given by -3, 3, 5, C, where the values A, B, and C are all elements of the real numbers. Now, given this, the question asks us to find the values of A, B, and C such that capital A matrix times capital B matrix is equal to capital C matrix transpose. Now, with that, they say, with these values of A, B, and C that you found, find the matrix capital D such that capital A matrix times capital B matrix whole thing transposed times capital D matrix is equal to 2i plus capital C matrix, where I is the identity matrix of order 2. Now, to start off with this question, let's write down the equation capital A matrix times capital B matrix equals capital C matrix transposed and substitute in each of these three matrices. So, writing this down, we can see we have capital A matrix times capital B matrix equal capital C matrix transposed, and substituting in the matrices, we can see for capital A matrix we have the matrix 2A1, 3, negative 1, 1. So we have 2A1, 3, negative 1, 1 times the other matrix, which is 3 by 2 matrix, negative 2, 0, B2, 2, 3. And that is equal to C matrix transpose, which is the matrix negative 3, 5C transposed. Now, on the left hand side, we can see we have two matrices multiplied together, and we can also see the first matrix is 2 by 3 and the second matrix is 3 by 2. Now, as we know, if this number and this number are equal, the two matrices are multipliable and the resultant matrix will be 2 by 2. It will be the other two numbers' size. Now, according to this, we can see the answer on the left hand side is a 2 by 2 matrix. Now, since on the right hand side we also have a 2 by 2 matrix, we can say this equation for now looks valid. Now, if we consider multiplying here, what we have to do is to draw a 2 by 2 matrix on the left hand side, and inside this 2 by 2 matrix we need to apply the multiplication algorithm for these two matrices. Now, here we have four spaces: the space 1, 1, the space 1, 2, the space 2, 1, and the space 2, 2. Now, as we know, if we want to fill the space in row 1, column 1, what we have to do is to multiply the first row of the first matrix by the first column of the second matrix. So, therefore, in order to get this element, we have to multiply each of these by each of these. So, going through, we can see the first value is 2 times negative 2, which is equal to negative 4. And therefore, the first element here is going to have a negative 4 at the front. And then to that, we have to add the next value, which is A, times the next value, which is B. So we have plus A times B. And the next value is 2 times 1, which is 2. So plus 2. Now, considering the next value here, we have row 1, column 2. So for row 1, column 2, we have to multiply row 1 of the first matrix by column 2 of the second matrix. So multiplying these two, we can see the first value we get is 2 times 0. So we have 2 times 0, which is 0. So I'll just add 0. And then we have A times 2, so 2A, so plus 2A, and 1 times 3, so plus 3. Now for the next value here, which is in row 2 and column 1, we have to multiply row 2 of the first matrix by column 1 of the second matrix. Multiplying these two, we can see the first value we get is 3 times negative 2, which is negative 6. The next value is negative 1 times 2, or rather negative 1 times B, which is negative B. And the last value is 1 times 2, which is going to be 2, so plus 2. And for the last value, we have row 2, column 2, and therefore we have to multiply row 2 of the first matrix by column 2 of the second matrix. So multiplying these two, we can see we have 3 times 0, which is 0, and minus 1 times 2, which is minus 2, and 1 times 3, which is plus 3. So this is the matrix that we have on the left hand side. Now on the right hand side, we have the matrix -3, 5C transposed. Now what it means to transpose a matrix is to simply swap the indexes of the rows and columns. Now considering that, if we have the element here which is in row 1, column 1, if we swap the rows and columns, 1 swaps with 1, leaving us with 1, 1 again. So therefore, row 1 column 1 will swap to row 1 column 1 in the final matrix. So here it will still be minus 3. Now similarly, since C is in row 2 column 2, when you swap the rows and columns, you'll still have row 2 column 2, and therefore C is still here. However, for the other two, this value of 5 is in row 2 column 1, and if we swap the two, that means it will go to row 1 column 2, and therefore this element of 5 goes to this position right here, and similarly this element in row 1 column 2 goes to row 2 column 1, which is over here. So according to that, this is the matrix we got on the right hand side, and this is the matrix that we get on the left hand side, and since they are both 2 by 2, they can be equal to each other. Now with this, what we have to do is to exercise the rule for two matrices of the same size to be equal to each other. If these two matrices are equal to each other, then every element in the first matrix must be equal to the corresponding element in the second matrix. So according to that, we can say, if the above two matrices are equal, two matrices are equal, then row 1 column 1 matrix element, which is this element here, must be equal to the same element over here. Similarly, row 1 column 2, which is this element, must be equal to row 1 column 2 in this matrix. And similar for this should be equal to this. And finally, this should be equal to this. Now according to that, we can make four equations. The first equation we get is minus 4 plus AB plus 2, which I'll actually simplify to AB minus 2, AB minus 2 equals the corresponding element in the second matrix, which is minus 3. So AB minus 2 equals minus 3. The next thing we get is 2A plus 3 equals 5. We can substitute and write 2A plus 3 equals 5. And the next one we get is minus 6 minus B plus 2 equals minus 3. So simplifying this down, we can see minus 4 minus B equals minus 3. Minus 4 minus B equals minus 3, and the last one we get is 0 minus 2 plus 3, or plus 1 equals C. So we get 1 equals C. Now 1 equals C already gives one of the values. So we already have C equals 1. For the others, we need to take the other three equations and try and rearrange them to get what we want. But we can actually see we already have those directly. If we just take this to the other side and divide by 2, we'll get A, and if we just take this minus 1 to the other side and divide by minus 1, we'll get B. So taking these equations, if I label this 1, 2, 3, and just for the sake of it, we'll label this 4, and I take equation number 2, we can see from 2, by rearranging, we get 2A equals 5 minus 3, which is 2, and therefore we get A equals 1. And similarly, if we take equation 3, we can see we can get minus B equals minus 3 minus negative 4, which is plus 4, which is equal to 1, and therefore B equals minus 1. And with that, we have found the values of A, B, and C. Now after that, the question then says, with these values of A, B, and C, find the matrix D such that A matrix times B matrix whole thing transposed is times D matrix is equal to 2I matrix plus C, where I matrix is the identity matrix of order 2. Now I'll just tell you, the identity matrix, if you don't remember, is the matrix 1, 0, 0, 1. And in general, the identity matrix of an n by n size or order n is going to be the matrix that is of order n by n, where everything is 0 except for the principal diagonal. This diagonal is equal to 1 and everything else is equal to 0. Now moving on from that, if we just consider this equation for a second, you will notice that here we have AB, and AB is equal to C transpose. So therefore, if I do the substitution without actually solving it, I'm not going to solve it yet, I'll show you a little something that we need and then I'll solve it. If we consider substituting AB as C transpose, we get C transpose times D matrix equals 2Y times C, or rather plus C. Now here, C matrix transpose is just the C matrix transpose twice. And if we transpose, i.e. swap the rows and columns twice, we'll get back to the original rows and columns. So due to that, transposing a matrix twice is just going to be equal to the original matrix. If we do P matrix transpose, it is just equal to P matrix. Now according to that, what we really have in this equation, if we do some simplification, is just C matrix times D matrix equals 2y matrix plus C matrix. Now for this, in order to get rid of the C here, to get only the D, we need to multiply by C inverse matrix. Now in order to multiply by C inverse matrix, we need to find C inverse matrix. So before I actually tackle this equation, I'm going to try and find C inverse matrix, and after doing that, we'll try and find the matrix D. Now to find C inverse matrix, let's first write down C matrix. So C matrix is -3, -3, 5C, where C is equal to 1. So therefore going down, we can write C matrix equals -3, -3, 5, 1. Now given any matrix, let's say P, of the form A, B, C, D like so, the P inverse matrix is equal to 1 over determinant of P, which is AD minus BC, times the matrix where these two values are swapped, so we get D here and A here, and these two values are multiplied by -1. So here we get minus B and minus C. Now this matrix will only exist if AD minus BC is not equal to 0. And if it's not equal to 0, then we can substitute in this equation to get P inverse matrix. So therefore, what we need to do first is to check if that value of determinant is equal to 0, and if it's not equal to 0, we can directly substitute the formula to get C inverse matrix. So first, let's try to find the determinant of C, which is written as det C and sometimes written as modulus of C like this. So det C is equal to these two terms multiplied, which is -3 times 1 minus these two terms multiplied, which is -3 times 5. Simplifying this down, we can see the first term is -3 and the next one is minus -15, which is equal to plus 15, and therefore we get plus 15 minus 3, which is plus 12. So the answer is 12. And since 12 is not equal to 0, we can say C inverse matrix exists. And with that, we can directly substitute the formula to find C inverse matrix. So from this, we get C inverse matrix equals 1 over det C, which is equal to 12. So 1 over 12 times the matrix where the first two values here, these two, are swapped. So we have 1 here and -3 here, and these two values are multiplied by -1. So we have 3 here and -5 here. So this is the C inverse matrix. Now with the C inverse matrix, what we're going to do next is to take this equation and do what we did previously in order to find the value of the D matrix. So taking this matrix equation down, we can see we have AB matrix transposed times D matrix equals 2 times the identity matrix plus C matrix. Now from this, what I'm going to do is to do the substitution that I did, where instead of AB, I put C transpose. So therefore we have C transposed times D matrix equals 2Y matrix plus C matrix. And from this, I'm going to cancel these two transposes, since transposing twice does nothing. And therefore we get the matrix C matrix times D matrix equals 2Y matrix plus C matrix. And finally, in order to get the D matrix, I need to multiply both sides of this equation on the left hand side by C inverse matrix. So therefore, we get C inverse matrix times C matrix times D matrix equals C inverse matrix times 2Y matrix plus C matrix. Now here it should be noted that since we multiply on the left hand side by C inverse matrix, on the right hand side, we also have to multiply on the left by C inverse matrix. You cannot put the C inverse matrix over here. It has to be on the left hand side. Now if we simplify this, we can see on this side we have just D matrix, and on this side we have C inverse matrix times 2Y matrix plus C matrix. And now all we have to do to find D matrix is to simply substitute C inverse matrix, I matrix and C matrix. So doing so, we can see we get 1 over 12 times 1, 3, -5, -3 times the other matrix here, which is equal to 2 times the other matrix, or 2 times 1, 0, 0, 1, plus the C matrix, which is equal to -3, -3, 5, 1. So -3, -3, 5, 1, -3, -3, 5, 1. Now simplifying down, we can see we have 1 over 12 times 1, 3, -5, -3 multiplied by the matrix here, the 2 by 2 matrix, which is 2 times 2, which is 2, minus 3, which is -1, and then 2 times 0 which is 0, minus 3 which is minus 3, so this element is minus 3, and then we have 2 times 0 which is 0, and plus 5 which is going to be equal to 5, so plus 5, and then we have 2 times 1 which is 2, plus 1 which is going to be equal to 3, so we have 3 here. Now with this what we can do is to multiply them together, and we can see we get 1 over 12 times a 2 by 2 matrix where the first element is going to be equal to row 1 column 1, so row 1 times column 1 which is 1 times negative 1 and 3 times 5. So we had negative 1 and plus 15 which is equal to plus 14, so 14. The next element here is row 1 column 2, so row 1 column 2 which is going to be 1 times negative 3 and 3 times 3 which is minus 3 plus 9 which is equal to plus 6. The next element after that is going to be this element which is row 2 column 1, so row 2 column 1 which is going to be equal to negative 5 times negative 1 which is going to be equal to plus 5 and minus 3 times 5 which is minus 15. So plus 5 minus 15 is minus 10. Now the final element here is row 2 column 2, so row 2 column 2 which is going to be equal to minus 5 times minus 3 which is equal to plus 15 and minus 3 times minus 3 or plus 3 which is equal to minus 9. So plus 15 minus 9 which is going to be equal to again plus 6. Now in this we can see we can divide everything by 2, and doing so we get 1 over 6 times 7, 3, negative 5, 3, and that is going to be the final answer for this question. Now finally, let's go up and discuss the marks overall for this question. So at the start of the question, when you take this matrix equation, substitute in the matrices and simplify for multiplying these two like so to get this side, and then taking the transpose of this to get this side and equating them like this, you get 10 total marks. Now after that, when you then apply the conditions of equivalence of two matrices onto these two, and then from that get these 4 equations, for getting any two of the first 3 and the last one, you get 10 total marks. Now after that, when you then take this equation, simplify, substitute and get the values of a, b and c as a equals 1, b equals negative 1 and c equals 1, you get another 5 marks. Now after the second part, when you then find the value of C inverse matrix from C matrix either before or after you need it over here, you get 5 marks for finding determinant and seeing it's not equal to 0, and another 10 marks for finding the C inverse matrix. Now after that, when you then take the equation you're given, do some substitutions, do some rearrangements, you get 5 marks for that, and then you do some more substitutions and some more rearrangements, multiply both sides by C inverse matrix and get to this point, you get another 5 marks. Now after getting to this point where you have D matrix equals C inverse times 2y plus c and substituting and then getting the final answer of 1 over 6 times the 2 by 2 matrix 7, 3, negative 5, 3, you get a final 10 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.